Let's move on the next topic, Azure Table Storage. Azure Table Storage is a cloud-based service that offers a key/attribute store with a schemaless design for non-relational structured data, commonly referred to as structured NoSQL data. Because table storage is schemaless, it's simple to modify your data as your application's requirements change. Many different applications may quickly and affordably access data stored in stable storage, whereas standard SQL is often more expensive for data volumes that are comparable. You can utilize table storage to keep track of flexible datasets like user information for web applications, contact information, device data, and other kinds of metadata needed by your service. Up to the storage account's capacity limit, a table can include any number of entities and a storage account can contain any number of tables. Large volumes of structured data are stored in Azure Table Storage. The service, a NoSQL data store, supports authenticated requests from both inside and outside the Azure cloud. Azure tables are suitable for storing organized, non-relational data. Typical applications for table storage include storing TBs for structured data capable of supporting web-scale applications, storing datasets that do not require sophisticated joins, foreign keys, or stored processes and can be denormalized for rapid access, using a clustered index, quickly querying the data. Using the WCF data service, NET libraries, one can access data using the OData protocol and LINQ queries. You may utilize table storage to store and query massive amounts of structured, non-relational data, and your tables will scale as demand grows. Azure Queue Storage will be discussed next. It is a service that allows for storage of several messages. Using HTTP or HTTPS authenticated calls, you can access messages from anywhere in the world. A queue message may have a maximum size of 64 KB. Millions of messages may be in a queue up to the storage amount's maximum capacity. Queues are frequently used to build up a backlog of tasks for asynchronous processing. Queue storage components include URL format. Queues can be addressed using the format of a URL. Storage account. A storage account is required for any Azure storage access. A queue is a collection of messages. The queue name must be written in lowercase only. Message. A message of up to 64 KB in any format. Prior to version 2017-07-29, a maximum time to live of 7 days was permitted. The maximum time to live can be any positive value of versions 2017-07-29 or later, or -1 to indicate that the message never expires. If this parameter is not specified, the default time to live is 7 days. Now that we are clear on what Azure Storage is and why businesses use it, let's discuss how to use Azure Storage effectively for all of your development needs. Azure Storage Explorer is the tool we utilize for such tasks. As you work with Azure Storage Explorer serves as a potent tool for swiftly accessing the data and modifying it as necessary. Azure Storage Explorer is a graphical user interface based tool that includes a slew of features to make development easier. Connecting to and managing numerous storage accounts is simple. You can connect any device to your Azure Storage accounts with Azure Storage Explorer. It is a free utility that works with a variety of OS including Windows, Linux, Mac OS, etc. Azure Storage Explorer is a viable option that allows you to connect to any Azure storage from any device on any platform. You can create or alter tables, blobs, queues, and files after logging into your account. Additionally, you may connect to and work with Azure Data Lake Storage and Azure Cosmos DB Storage using Azure Storage Explorer. You can employ a variety of storage and data operation tasks with Azure Storage Explorer on any of your Azure storage accounts. Editing, downloading, copying, and deleting are some of these tasks. Azure Storage Explorer has several advantages, including the first benefit is that it is extremely safe. It encrypts all of the data kept in Azure storage. Additionally, it gives you the power to decide who and how much of your data can be accessed. It is also scalable. Azure Storage Explorer is extremely scalable and a perfect match for the requirements of the current application stack. Organizations favor it greatly because of its versatility. It is enduring as well. Data security is ensured via redundancy in the event of hardware failure. You can copy your data to safeguard it from any disaster. When data is replicated in this way, it is always accessible even if there is an unplanned outage. Azure takes care of key issues, updates, and hardware maintenance. Data stored in Azure storage can be accessible from any location in the world with a reliable internet connection. It's simple to accomplish using Azure Storage Explorer. For dealing with your data, Azure Portal and Azure Storage Explorer provide simple visual options. Let's move on to the next subject, SAS. A shared access signature (SAS) enables secure delegated access to your storage account's resources. With a SAS, you have fine-grained control over how a client can access your data, for instance, the resources that the client can use. What rights do they have in relation to those resources? How long is the SAS valid? Shared access signatures are supported in 3 different ways by Azure Storage. The first is SAS user delegation. A user delegation SAS is protected by Azure Active Directory, Azure AD credentials as well as the permissions assigned to the SAS. Only bulk storage is affected by a user delegation SAS. The second is service SAS. A storage account key protects a SAS service. SAS delegated access to only one of the Azure storage services, bulk storage, queue storage, table storage, or Azure files. Finally, we have account SAS. The storage account key protects a SAS account. Access to resources in one or more of the storage services is granted by an account SAS. An account SAS has access to all the same operations as a service or user delegation SAS. Access can also be delegated for additional tasks, including operations that are performed at the service level, such as the get/set service properties and get service stats procedures. Operations that are prohibited when using a service SAS, including reading, writing, and deleting. 2 types of shared access signatures are available. First, there is ad hoc SAS. The start time, expiry time, and permissions are supplied in the SAS URI when you construct an ad hoc SAS. Ad hoc SASs can be of any SAS type. Finally, service SAS with saved access policy. A resource container such as a table, queue, file share, or bulk container can define a stored access policy. One or more service shared access signatures can have their restrictions managed using the stored access policy. The start time, expiry period, and permission specified for the stored access policy are passed along to the service SAS when you associate it with the policy. Use an SAS to grant any client who would not otherwise have authority to access those resources secure access to the resources in your storage account. A SAS is frequently helpful in situations where users can read and write their own data to your storage account. There are two common design patterns when user data is stored in a storage account. Clients use a front-end proxy service which authenticates users to upload and download data. This front-end proxy service enables business rule validation. The cost or difficulty of developing a service that can scale to meet demand may be higher or greater for big amounts of data or high volumes of transactions. A quick service generates an SAS after necessary client authentication. The storage account resources can be directly accessed by the client application once it has received the SAS. The SAS establishes access restrictions during the time period it permits. The SAS reduces the requirement for data to be sent only through the front-end proxy service. A combination of these two methods may be used by many services in the real world. For instance, the front-end proxy might be used to analyze and validate some data. SAS is used to directly save and/or read other data. Additionally, in some circumstances, an SAS is necessary to provide access to the resource object during a copy operation. When a blob is copied to another blob located in a separate storage account. To approve access to the destination blob as well, you can opportunistically employ an SAS. When you copy one file to another on a different storage account. To approve access to the destination file, you can further utilize an SAS. When a file is copied into a blob or vice versa. Even though the resource and destination objects are located in the same storage account, an SAS must be used. We'll discuss Azure Data Box in this session. The Microsoft Azure Data Box cloud solution allows you to send terabytes of data into and out of Azure in a timely, cost-effective, and dependable manner. Your receiving a custom data box storage device speeds up the safe data transfer. Each storage device is shipped to your data center by a regional carrier and has a maximum usable storage capacity of 80 TB. The device includes a tough case to safeguard and protect data while in transit. You can order the data box device through the Azure site for data import or export from Azure. You can easily configure the device using the local web UI once it has been received. Copy the data from your servers to device or from the device to your servers as appropriate, then mail the device back to Azure depending on whether you plan to import or export data. When importing data to Azure, your data is automatically uploaded from the device to Azure in the Azure Data Center. The data box service in the Azure interface keeps track of the procedure from beginning to conclusion. When there is no or little network connectivity, data box is well suited to transfer data quantities greater than 40 TBs. The data transmission might be one time, repeated, or it can start as a bulk data transfer and then continue with periodic transfers. These are the several situations when Databox can utilize to import data to Azure. One-time migration. The transfer of a sizable amount of on-premises data to Azure. Creating an online media library by moving a media library from offline tapes into Azure. Moving your virtual machine farm, SQL Server and applications to Azure. Using HD Insight, move historical data to Azure from in-depth analysis and reporting. Initial bulk transfer. When an initial bulk transfer is performed using a Databox seed followed by incremental network transfers. For instance, initial large historical backups are transferred to Azure using backup solution partners like Commvault and Databox. The incremental data is then sent to Microsoft Azure storage across the network. Periodic uploads. When a lot of data needs to be transferred to Azure regularly, for instance, in the production of film for energy exploration, which takes place on wind farms and oil rigs. Here are some of the several circumstances in which Databox can be utilized to export data from Azure. Disaster recovery is the process of restoring an on-premises network with a copy of the data from Azure. Unusually huge amount of Azure data are exported to a Databox in a disaster recovery scenario. Following Microsoft's delivery of this Databox, you quickly receive the data back on your premises. Security needs. When you have to be able to export data from Azure because of legal or security requirements. For instance, you can utilize Databox to export data from Azure, and Azure storage is accessible in the US secret and top secret clouds. Remigrate workloads to on-premises or another cloud service provider by exporting data using Databox when you want to move all of the data back to on-premises or another cloud service provider. Large amount of data can be transferred to Azure using Databox with little to no network effect. Numerous advantages of the solution include speed. Databox can move up to 80 TB of data into and out of Azure using 1 Gbps or 10 Gbps network ports. Secure. The device, data, and service are all protected by internal security measures in Databox. The device has a tough case that is held together by tamper-evident stickers and tamper-resistant screws. AES 256-bit encryption is always used to protect the data stored on the device. Only the password provided on Azure site can unblock the device. The Azure security mechanism guard the service. The disk on the device are completely erased in compliance with NIST 800-88R1 guidelines when the data from your import order is uploaded to Azure. Once the device reaches the Azure data center, the disks are wiped from an export order. Let's move on to the next topic, Azure Storage Replication. Azure Storage makes and stores copies of data across many locations in order to preserve data availability and durability. This is known as storage replication. Redundancy is intended to protect data from hardware breakdowns, power outages, and network failures. You have a variety of redundancy choices at your disposal. Data replication is possible both within a single region and in a secondary region that is geographically distant. To ensure availability during disasters, you can also enable read access to replicated data that is stored in a backup area. A primary region receives data replication from Azure Storage 3 times by default. Azure also provides a few configuration options you can use for replication inside the main region. The first option is locally redundant storage (LRS), which synchronously replicates data to three disks inside a primary region data center, offers a reasonable price and a moderate amount of availability. The secondary option is zone redundant storage (ZRS), which synchronously replicates data among three Azure availability zones. At a higher cost, it provides a better level of resistance. In addition to these two basic methods of replication, Azure Storage supports three others. Geo-redundant storage (GRS) maintains three additional copies of the data in linked Azure regions. Read Assess Geo-redundant (RA-GRS) is identical to GRS and enables the reading of data from both Azure regions. Object replication for blob storage is a unique form of replication used specially for blobs, duplicating them across a source and target storage amount. Let's talk in depth about these types. To start with locally redundant storage (LRS), LRS replicates data three times within a single data center in a major region. Once data has been written to three copies, Azure Storage only recognizes write requests as successful when LRS is enabled. During a specific year, LRS offers at least 99.999999999% durability for things. You can protect your data from drive failure and serve rack failure with the low-cost LRS service. Though not all data loss scenarios are covered by LRS. Use LRS if your data is less vulnerable to use or if it must be kept in a single location for regulatory reasons. Zone redundant storage is the next option, ZRS. ZRS replicates data between three Azure availability zones. A distinct physical location, each Azure availability zone has its own separate networking, power, and cooling systems. ZRS guarantees at least 99.999999999% object durability over the course of a year. Data is kept available even if an availability zone is down thanks to ZRS. Both read and write procedures are true in this regard. Data is only reliably written to all three availability zones before Azure Storage considers a write operation successful. To guarantee consistency, high availability, and durability in a primary region, use ZRS. Next, there is geo-redundant storage (GRS). Compared to LRS or ZRS, GRS offers more redundancy for data storage. There are three copies of the data saved in a paired Azure region in addition to the three copies in one region. As a result, GRS offers all the features of LRS storage in the primary zone as well as secondary LRS data storage in a different location. The read and write SLAs offered by Microsoft for ZRS and LRS data storage are the same because all read and write activities are still controlled by a single Azure data center. The GRS redundancy has two drawbacks. Due to the asynchronous nature of replication between regions, data propagates with a slight delay. No access or reading is possible until the storage account fails over in the second location. In addition, there is read access geo-redundant RA-GRS. The secondary copies kept in paired Azure regions are readable in addition to having the same level of redundancy as normal GRS replication. This implies that you can use numerous readable endpoints if your application is configured properly. The SLA for read operations is raised to 99.99% as a result. Because write and update operations are still managed by a single region, the SLA for write operation is still 99.9%. Both methods of GRS replication experience some replication latency as a result of their asynchronous replication. To make sure you are reading the most recent copy of the data, utilize the latest sync time argument. Finally, there is object replication for blob storage. All Azure storage services could benefit from the replication techniques that came before. This unique replication technique is exclusively accessible for blob storage. The replication method for objects is asynchronous. To improve data distribution and cut expenses, you can utilize it to automatically shift data to an archive layer. Or to reduce latency, you can utilize it to synchronize data with a storage resource that is located closer to your consumers. Blobs are duplicated in accordance with your replication policy, which outlines which blobs should be replicated as well as the resource/target Azure accounts and containers. Blob object replication copies are blob version, blob content, and blob metadata. We'll talk about the Azure import/export services in this session. Large volumes of data can be safely imported to Azure files and blob storage by sending disk drives to an Azure data center using the Azure import/export service. Additionally, you can use this service to move data from Azure blob storage to hard drives and delivers it to your on-premises facilities. You can import data from one or more hardware drives into Azure files or Azure blob storage. Utilize the Azure import/export service to move data using your own hard disks. Microsoft supplied disk drives are also an option. Use Azure Databox disks to import data into Azure if you want to transfer data utilizing disk drives provided by Microsoft. Microsoft uses a local carrier to deliver up to 5 encrypted solid-state disk drives (SSDs) with a 40-bit total capacity to your data center for each order. Fast hard drive configuration, data copying over a USB 3.0 connection, and return shipping to Azure are all possible. When downloading or uploading data over the network is too slow, or obtaining additional network capacity is prohibitively expensive, take into account using the Azure import/export service. Utilize this service in the provided situations. The first scenario is cloud movement of data. Transfer massive volumes of data to Azure fast and affordably. Content dissemination follows next. Send data to your consumer's site as soon as possible. Then there is backup. Your on-premises data should be backed up and stored in Azure storage. In conclusion, data recovery delivers massive amounts of data that have been saved in storage to your on-site location. Some components used by import/export services include import/export service. The Azure portal service facilitates the creation and monitoring of data, import, upload, and export download jobs. WA import-export tool. Examples of what this command line utility can perform are: get ready to import your supply disk drives. Allows you to copy your data to the drive more easily. AES 256-bit BitLocker is used to encrypt the data on the drive. You can safeguard your BitLocker key using an external key protector. Creates the drive journal files required for import creation. Assists in determining the number of drives required for export jobs. Disk drives. You can send SSDs or HDDs to the Azure data center. You send data containing disk drives when you create an import job. You send empty disks to Azure data center when you create an export task. By generating jobs, the Azure import/export service enables data transfer into Azure files and Azure blobs. To create jobs, use the Azure portal or the REST API for Azure Resource Manager. A single storage account is linked to each job. Import or export employment is also possible. While an export task allows data to be exported from Azure blobs, an import job allows data to be imported into Azure blobs or Azure files. You send drives containing your data to an import task. In order to send empty disks to an Azure data center, you must build an export task. You may send up to 10 disk drives per job in each scenario. An import task entails the action at a high level. Choose the data to be imported, the number of disks you will need, and the Azure storage destination blob location for your data. If you want to copy data to disk drives, use the WA import-export utility. BitLocker disk drive encryption. Create an import job in the Azure portal for your desired storage account, the journal files from the HDD. Give your carrier account number and return address so they may ship your disks back to you. Disk drives should be sent to the shipping location specified during job creation. In the import job details, update the delivery tracking number, then submit the import task. At the Azure data center, the disks are received and processed. The drives are sent to the return address specified in the import job using your carrier account. You can connect to external storage accounts using Microsoft Azure Storage Explorer to make it simple to share storage accounts. In order to share an external storage account, the account's owner must first obtain the account's credentials, account name and key, which they must then give to the person who wishes to attach to the account. By following the given instructions, you can get the credentials for the storage account using the Azure portal. Log in to the Azure website. Then Accounts for Storage. Choose the chosen storage account from the list of storage accounts. Go to the settings and choose Access Keys. Copy the key and name of the storage account. Connect to a storage account for external devices. You must have the account name and key in order to attach to an external storage account. How to receive these values through the Azure portal is described in this section titled Get the Storage Account Credentials. However, the account key is referred to as a key 1 in the site. So you enter the key 1 value when Storage Explorer prompts you for an account key. Access the Connect dialog by opening Storage Explorer. Choose Use a storage account name and key from the Connect dialog. Select Next after pasting your account key, the key 1 value from the Azure portal, into the account key text box and your account name into the account name text box. Verify the data in the Connection Summary dialog box. Select Back, then input the desired parameters once more if you need to make any changes. Choose Connect. The storage account is shown with the words External after its name once it has been successfully attached. Select Detach from the context menu when you right-click the external storage account you want to remove. Select Yes to confirm the detachment from the external storage account in the confirmation message. You can quickly copy data using the Copy Data tool in Azure Data Factory by following these instructions. Select the ingest title on the Azure Data Factory homepage to launch the Copy Data tool. Select Next after selecting built-in copy task under task type on the properties screen for the Copy Data tool. To add a connection, click plus Create New Connection. For the source connection, choose the associated service type you want to build. From the gallery, choose it, then click Continue. Give your connection a name on the New Connection page. Choose Create after choosing Test Connection and then selecting your storage account from the list of storage account names and your Azure subscription from the list of Azure subscriptions. In the connection block, choose the newly formed connection. Select Browse to access the Add Tutorial/input folder. Choose the emp.txt file and then click OK in the File or Folder section. To duplicate the file exactly as it is, check the binary copy box, then choose Next. Pick the connection for Azure Blob Storage that you have made in the connection block. Enter a dev tutorial/output as the folder path in the folder path box. Select Next after leaving the other settings alone. Choose Next to use other default configurations after giving the pipeline a name and a description on the settings screen. Review all of the settings on the summary screen, then click Next. Choose Monitor from the Deployment Complete page to keep an eye on the pipeline you built. The Monitor tab is selected by the application. On this tab, you can view the pipeline status. To reload the list, select Refresh. To check activity, run information, or rerun the pipeline, click the link next to the pipeline name.